everyone. Thank you for coming to this bite-sized session. I'm Georgina Martin. I'm an Associate Solutions Engineer at Couchbase, and today I'm going to be talking a bit about machine learning on the edge. So first of all, I'm going to talk a bit about what it actually is, what is machine learning, and what is machine learning at the edge specifically, why we might want to do this, and how we can use predictive querying to help build machine learning at the edge applications. So what is it? How do we define machine learning? Machine learning is essentially a branch of artificial intelligence and computer science, and it focuses on using data and algorithms to imitate the way that humans learn. So, for example, in this diagram that we see here, we have in the middle a machine learning model, and this is the set of algorithms that are trained to be able to learn to do a particular task. So in this example, it is a classification task. You input an image and you get out of your machine learning model a label for the prediction of what is shown in that image and the probability that that is the correct label. And then what is the edge? So the edge is a term that refers to a location which is far from the cloud or a big data center where you have a computer device, an edge device, which runs an edge application. So machine learning at the edge is the combination of this, performing using a machine learning model on a device that is running an edge application. So here is an example of a centralized database with edge devices connected to it. So if we think for a minute about how machine learning might have been used in an application prior to implementing machine learning at the edge, we might have, in the example of a classification model, taken an image, a photo with a smartphone, sent that photo to the central data service to do some processing, to get a prediction for that image and then return it to the smartphone. But there are a few potential issues with that. So one being it requires the internet, it requires internet connection to be able to transfer that data. So in the event that you don't have connection, you won't be able to use your end user will have a poor experience of trying to perform that function and not having it work because of the lack of connection. There's also the possibility of having poor network connection, so a high latency, and the end user being dissatisfied with not being able to get the expected results in a timely manner. There's also infrastructure costs, the costs associated with having to transfer this data over the network, as well as security and privacy requirements. Having to transfer it to a central data center is going to require having a certain level of security or privacy. So being able to perform this at the edge has the advantage of being able to do whatever processing you need for that user locally without the extra costs associated with the network or with the security and privacy requirements. So a few examples of where this might be used, of how you might use machine learning at the edge is, for example, with a recommender system on a smartphone or a laptop. So being able to take information, use information collected on that particular device, whether it's location, weather, and also making use of the particular user's previous history of that application use, and being able to provide recommendations based on that information. So another potential use case is face-based loyalty. So in this example, we have a self-service kiosk. If a user walks up to it and has used it before, potentially you might be able to recognize what the user is and make recommendations for what they might like based on previous uses. And of course, something like security is going to be a major concern in that case. So being able to do that locally on the device is going to be very important. So how can predictive querying actually help with this? There's going to be a lot of concerns around how you actually execute this, being able to use a pre-trained model, being able to make those predictions, and then use existing data to incorporate your prediction for the input image, and then get your predictions based off that existing data. There's a lot of complexity there, so how do we actually go about building an application that would make use of that? So before I go too much into what predictive querying is and how we can use it, I'm going to give a quick overview of the Couchbase mobile platform, so that you have a bit of context when I talk about how predictive querying works. So Couchbase is a distributed NoSQL database, and you can deploy it in a variety of ways, whether that's on cloud, on-prem, hybrid cloud, or on mobile and edge devices. So the mobile or edge deployment is called Couchbase Lite. So looking at this sort of high-level architecture diagram, the most important bit to pay attention to is these edge devices along the bottom. Mobile, desktop, or embedded applications have Couchbase Lite locally on these edge devices. And that allows the application to store the relevant application data and information relevant to the particular user who is using that device. And being part of the Couchbase platform, you're also able to sync this data with the central server that's shown up here and sync that in a secure way. So the takeaway, the most important part of this going forward is, in this presentation, Couchbase Lite instances, and that's where we're going to actually look at how you make use of a machine learning model. So what is predictive querying? It is an API which allows mobile applications to leverage a pre-trained machine learning model to make predictions based on data that you already have in your database, in your Couchbase Lite instance. And then being able to combine predictions from input from a user on the application with the existing information that you already have in the database. So it's that particularly the combination of the input data and the existing data. So why might you want to do this? This is a complex process with a lot of stages to actually be able to integrate all of the steps and come out with the predictions and recommendations based on the existing data. So with predictive queries and with predictive indexing, you're able to see significant improvement in performance and have much greater ease when actually building applications which might use machine learning at the edge. So you're able to have fast, local applications and that will always be available offline. So Couchbase Lite instances that are stored on the embedded device or on the edge device will always have that data available to them, regardless of whether or not there's network connectivity. So if you lose internet connection for some period of time, your user is not going to be impacted. They're still going to be able to access the data required for the application. And very importantly, you're not going to have those same privacy concerns, given you're able to do all of that processing locally on the edge device. And then you will be able to sync the required data between different edge devices to be able to share information when required. So here we see a sample application that was built on Couchbase Lite using predictive querying. So in this sample application, the user is selecting an image from the photo album and then looking up matches of data that's already in the database to find the closest matches. And you can see how quick that's actually happening, how quickly being able to, from uploading the image to immediately, or not immediately, but very, very quickly being able to find close matches. So this is a simple example, but can be used in a variety of ways. For example, the facial recognition that was mentioned earlier, or potentially recommendation systems. So there's a lot of potential functionality in this small sample application. So to take a quick look at the sort of architecture and how you go about doing this. There are a couple of prerequisites for using predictive querying and predictive indexes. So first of all, you need to have a pre-trained model. In this example, we're looking at a classifier. So like the example we discussed earlier, you input an image and get out a prediction of the class and the likelihood that that prediction is correct. The other thing that you need is a Couchbase Lite instance installed on an edge device. So once you have those two parts of the system, you're able to register the pre-trained model with your Couchbase Lite instance to be able to then use it locally, and actually make predictions based off of the data, both in your Couchbase Lite instance and through the pre-trained model. So the next step is to create an index, and this is where you're going to see the biggest improvement in performance when it comes to actually using predictive querying. There's a couple different types of indexes that you can build. There's a value index and a predictive index. So this is an example of a predictive index. And the way that works is it takes the data that you already have in your database that you want predictions for. It passes it through the pre-trained model to then get an output of the category shown by the image and the probability that that is the correct category. And then these predictions for each image that you want to index are stored in a predictive cache. And having that cache is how you get the really fast responses that we saw in the sample application. So the final step for actually performing a predictive query, once you have built the index, you take an input image. So this might be a photo that a user has taken on their smartphone, and make a prediction on the class with your pre-trained model and get an output for the predicted label and the probability that this is correct. And where the querying comes in is then being able to take that prediction that you've made and look at the data in your database and the predictions for those images that you might have stored, and be able to make comparisons, recommendations based on that. So from the category here, you filter for specifically items in the database that are part of that category and are able to find the matching items, as we saw in the example with the photo of a cup, then displaying the matches of other cups that are already stored in the database. So if anyone would like to take a look at the code for the sample application that I've shown, feel free to scan the QR code here. There's a couple different applications that are shown here. There is the classification one that we saw the GIF of earlier, and there is a facial recognition classifier on there as well. So I'll leave that up for a minute. If anyone would like to have a quick scan, I can go back to it later as well. So thank you for listening. I hope this has piqued your interest a bit in machine learning on the edge and on how Couchbase predictive querying might be able to help with that. Thank you. Before I take any questions, I just wanted to mention the raffle that we have going at the moment at the Couchbase booth. So if you wanted to come along and discuss any of what I've talked about, anything about Couchbase in general with me later today, we're doing a raffle for some Funko Pop heads. So come along at 6 p.m. You might be able to win one, and if you don't, there's plenty of free beer and soft drinks as well. I'll leave that up. Yes, any questions?
It's not clear, but is Couchbase open source, or like do we need a license to?
So there's a community edition of Couchbase, but to use it, it requires a license to use the enterprise version.
Okay.
Maybe question. Oh. Hey. Okay. So question for me, like you as an example, you say that that kiosk with face recognition for the customer. What would happen if? Okay. How can you predict that customer will go to this shop? Like, let's say you have a network of shops. How can you predict that actually the customer will go to this shop based on location or something like that?
So the example that I was talking about is the idea of based on a user who might have been to any of the shops before and might have a user document in the database with preferences, being able to the predictive querying would come in at being able to perform the facial recognition and get a fingerprint using a pre-trained model specifically for that. Something that can be done with Couchbase Lite, if I go back a few slides. So you're able to perform syncing, because you can sync data between the central server and the edge devices. You can keep private what needs to be private, and keep it on the device. But for a general sort of user profile, you're able to share that information between the different edge devices.
Thank you.
Yes, if you have any other questions later on, feel free to come talk to me or any other Couchbasers here about those questions. And if not, I hope to see you at 6 for a beer and the raffle.